Okay, let me start it up. And let me start up with a story that actually will have some implications for maybe one or two of you. So today I walked down the hall madly to my office and I noticed my door is open and my light is on. And I'm thinking, geez, last night I could swear I closed my door. And I always turn my light off. I round the corner in my office and there's a guy in my office. Somebody's stealing stuff on my office. No, I'm IT here, I'm IT. And he's replacing my phone. Yeah, actually, he's taking my phone, and we're supposed to be using an app on the computer. So I asked him about this, and said, hey, look, I know we got this email about it, but it said it was going to be in the future, so I didn't bother to read it. So the future is now. What am I supposed to do? It says, well, just install this WebEx app, and then you can use your computer, to make phone calls. Go, okay, fine. Since you're here, you're IT, install the thing for me. You know what to do. So he installs it and look at it and say, this doesn't look obvious to me. How do you make a phone call? I says, well, you do this, and then you do that, and then you type in the number, and I typed in the number, and it said, can't make a phone call. I go, hey, well, this doesn't look promising. And it says, well, okay, let's try this. And did that, can't make a phone call. I look and say, oh, look, it also changed my phone number. And he said, oh, I didn't know it would do that. I said, yeah, okay. And so we worked on the thing for about 40 minutes. I cannot make a phone call, I cannot receive a phone call, and my phone number changed. So I asked him, have you been installing this thing around for other people? And he goes, yeah, I have. I said, well, the way to think about this is that you screwed over all these other people because they can't make a phone call, they can't receive a phone call, and presumably their phone number changed. So he said, oh, yeah, I guess I have been doing that. Which, is one way to think about your life, that you're screwing other people over. But in any case, I had to put in an IT request for help. So if you're calling me, I'm not going to call back because I cannot make a phone call. But I can't even receive your phone call. And even if I could, my phone number's changed. So email me. And when you email me, do not use the Canvas email. I do not get that email. I put in an IT request for help for that, I don't know, 20 years ago or so, 15 years ago when economics got booted out of the business college and they couldn't fix it. So I can't get the Canvas emails. Don't email me using Canvas. Email me directly. Here, let me, as a matter of fact, put my email up on the board again. So it's easy enough to remember. It's just my name, Mark Rush, at ufl.edu. So if you need to contact me, email me, all right? And if you don't hear back within a day, email me again, because that means I've lost your email. So don't feel bad. Don't say, oh, he's going to hate me because I'm emailing again. No, I'm going to hate myself for screwing up and missing your email. For you, that's exactly what you should do. For me, it's exactly what I should not do. Okay, with that good? Yeah. Okay, let me talk about elasticity. Before I do, I don't drink coffee. Let me get some caffeine. Guys, I'll need it, and maybe you will too. Let me give you sort of a notion of what we're after with this idea of elasticity. Let's suppose we've got two markets. So here's market one, here is market two. Here's the price, here's the quantity, here's the price, here's the quantity. And let's say the supply curves in these markets are identical. So those supply curves look identical. What's going to differ between these markets, I thought I was getting a little musical background there, okay? What's going to differ between these two markets is the demand curve. Here I'm going to have a very flat demand curve here. So there's my very flat demand curve. Oops, that's the supply curve. So here's the equilibrium price. Here's the equilibrium quantity. Now over here, I'm going to have the same price and quantity. The difference is I'm going to have a very steep demand curve over here. So here's the price. Here's the quantity. So in both of those markets, we've got the same price, we've got the same quantity, the supply curves are identical. Let's suppose that the cost increases by the same amount. So the cost goes up in both markets. That means that the supply is going to decrease, going to shift to the left by the same amount in both markets. So here, let me shift the supply curve to the left like this. Here's S prime, so it's shifting to the left by that much. Let me get the same shift to the left here. And it looks like I came pretty darn close right there. And so now let's look at what happens in this market. So in this market right here, here the price rises to P prime and the quantity decreases to Q prime. So here I get an increase in the price and I get a decrease in the quantity. And you can see by the arrows, the price doesn't go up much, but the quantity goes down a lot. Now compare that to over here. Over here, here's the new equilibrium here. So here's the price, P prime goes up there. Here's the quantity, Q prime goes back there. So here we get the price going up a lot. We get the quantity going down just a little. So in both those markets, we get the same exact qualitative result. Okay, both markets, we have the price going up and the quantity decreasing, but there's a big quantitative difference between these. In the first market, the price went up only a little bit. Here it went up a lot. In the second market, actually in the first market, quantity went down a lot. Here it went down just a little bit. The reason that we get this difference in quantitative results is obviously the demand curve. Now, sometimes all we need to know is that the price goes up, quantity goes down. Other times we'd like to know, is it going to go up a lot or is it going to go up a little? Is it going to decrease a lot, decrease just a little? And so we'd like to get some handle on this. You know, can we make a more quantitative prediction about what's going to happen to the price or what's going to happen to the quantity? And that's what elasticity is going to try to do for us. Okay, it's going to give us a handle on making this more quantitative prediction. So when I look at these two things here, these two curves here, what do we see the difference? Well, again, the difference is in the demand curve. And the way you want to think about this is this demand curve right here, people respond very strongly to a change in the price. We get just a small increase in the price here, just a small increase in the price, and that leads to a really big decrease in the quantity demanded. Okay, so here what we see, people are very responsive to the change in the price. Now over here, let's look here. Here again, we move up along the demand curve. The price rises quite a bit, but the quantity decreases just a little bit. Okay, so here people are responding weakly. Right here, this is a very weak response. People don't change the quantity they demand very much, even in the face of a huge change in the price. So that's the key word. The key word here is responsiveness. And let me get rid of this right here. I just want to keep this word around. Okay, so the key word is responsiveness. How strongly do people respond to, in this case, to the change in price? Here, we see the price goes up a little bit, they respond strongly. They decrease the quantity, they demand a lot. Here the price goes up a lot, they respond very weakly. The quantity goes down only a little bit. And so that's what elasticity is going to give us a measure of, is how strongly people respond to something. In this case, how strongly people respond to the change in the price. So is that good? You guys okay with that? Now, we want some measure of this. So what you might think by looking here is I want to use the slope. Because, you know, clearly here, you know, the slope is smaller, here the slope is bigger, you know, this is flatter, that's steeper, so I want to use the slope. But there's an issue with using the slope. Let me show you what that issue is. I'm going to look at two different demand curves, and we'll calculate the slope on these two demand curves. So I've got the price, the quantity right here. Here is my demand curve. And I'll make the demand curve a straight line because that's going to be easy to calculate the slope on it. So let's suppose that when the price is 9, coming over here, that people buy, I don't know, 22. And let's suppose when the price is 11, people buy 18, whatever this may be. So, okay, there are 2 points on my demand curve. Now, the slope of a curve, the slope is equal to the rise divided by the run, or it's the change in the vertical axis, that's the rise, and typically this is y, but here it's p, so it's a change in the vertical axis, change in price, divided by the change in the run along here, the horizontal axis, the change in the quantity. So that's what the slope is equal to. Change in price divided by the change in quantity. And actually I can put this up here. So let me calculate the slope. And remember, this is a straight line, so the slope is the same at all points on it. So let me go from here to here. So it's going to be the change in the price. So it's 11 minus $9. So it's $11 minus $9 divided by the change in the quantity. So it's 18 minus 22. So this is 2 divided by -4. So the slope here is -1/2, or -1/2 is 0.5. So it's -0.5. That's the slope. Okay, and you say, well, fine, so what? It's -0.5. Let me show you another demand curve now. I'm going to come over here, look at another demand curve. And again, I'm going to have a straight line demand curve here. So here's my straight line demand curve. And let's say that when the price is 900 cents, people are going to demand 22. When the price is 1100 cents, people are going to demand 18. Okay, now let me calculate the slope here. So the slope here again is the change in the price divided by the change in the quantity. And so let's go from the top to the bottom. It's 1100 cents minus 900 cents divided by 18 minus 22. So this is 200 divided by -4, or this is what, -50. So we see the slope differs between these two demand curves. But if you think about this for a moment, you realize these demand curves are identical. Okay, the only difference is here I measure the price in dollars, and here I measure the price in pennies. That when I change the units on what I measure the price, that changes the slope. So that would say, if I use the slope, that if I measure things in dollars or pennies, I get different answers for the slope. Or if I look at a demand curve, say in the United States, and compare it with the demand curve, say in France, in the United States we use dollars, in France they use euros. Just the change in dollars to euros. Even if the demand curves are identical, the slope will change. Same thing would happen down here if I change the units here. Okay, if this was 18 and 22 tons, and I change it from tons to pounds over here, that would change the slope. The deal is the slope depends on the units. Okay, it changes when the units change. If I go from dollars to pennies to yen to lira to euros to pesos, the slope is going to change just by changing the currency in which I measure the demand. If I change the units here, down here on the bottom, if I go from pounds to kilograms to tons to long tons to short tons, again, it's going to make a difference in how the slope and what the slope is calculated to be. So the slope just doesn't work because it depends on these units. So the slope, we don't want to use a slope. So economists use something better. Economists use what's called the price elasticity of demand. Here's the definition up on the PowerPoint. I'm going to come over here and get rid of my email. So here, the price elasticity of demand, epsilon, is defined to be, so it's a definition. That means that there are 3 lines here. That's saying it's a definition. It's not saying like I said equals and then I twitched once. So it's the percentage change in the quantity demanded that is caused by the percentage change in the price, and we take the absolute value of that. And now, quite frankly, this is a pain in the butt to have to write all of this out like that way. So let me just shortcut it. It's a lot more common to write it this way. As a percentage, so there's the percent sign. Change, we use the Greek delta to mean change, and the quantity demanded that is caused by a percentage change in the price. I'm going to take the absolute value. Now, leave yourself space after this, okay, because I'm going to come back, I'm going to add stuff here, I'll eventually fill all this area down here, so leave space after in your notes. But for right now, let me discuss this a little bit. First of all, why do we take the absolute value? We're taking the absolute value because the law of demand tells us otherwise this would be negative. If we have a positive change in the price, we're going to get a negative change in the quantity demanded. So a negative number up here, a positive number down there, do the division, it's negative. Okay, so this would always be negative. And negative numbers are just intrinsically more confusing. You know, if I say, which is bigger, -5 or -3, you know, you tend to think -5 is bigger, but that's wrong. It's -3 that's bigger. All right, so, you know, we take the absolute value just to get rid of that negative sign. When you look online, I'm guessing, you know, it's a strong minority will take the absolute value, but it's increasingly common to keep the negative sign there, and I don't understand that because it just all does is confuse students. So we're taking the absolute value. Next, why am I using percentage changes? Well, percentage changes effectively cancel out the units. So that we're talking now about percentages, and that doesn't depend on the units, all right? So that's good for us, that we don't have to worry about the units anymore. So then, how then does this display responsiveness? I mean, I want to measure responsiveness. Well, let me give you a few examples. Let's suppose the elasticity equals 2, and that with that elasticity equal 2, suppose that the price changes by 10%. There is a percent change in price of 10%. How strongly are people going to respond? What's going to be the change in the quantity demanded? Well, look at this basic equation right here. And let me come over here and rewrite this basic equation. So it says the elasticity is equal to the percentage change in the quantity demanded divided by the percentage change in the price. And we take the absolute value. Then we multiply both sides by the percentage change in the price. So that's going to say that the elasticity times the percentage change in the price is equal to, and now when I multiply this side by the percentage change in the price, it's going to cancel this out. So it's going to equal the percentage change in the quantity demanded. And look, I lost the absolute value sign. What you have to remember here is that the price goes up, quantity demand is going to go down. It's going to be negative. Okay, so we just always have to remember that we've got this law of demand. Let me now use this right here. And what I can see now is that the change in the quantity demanded is going to be what? It's going to be the elasticity 2 times the percentage change in the price times 10%, or we'll get a 20% change in the quantity demanded. Okay, that as a result of this 10% increase in price, if the elasticity equals 2, that means that people are going to decrease the quantity they demand by 20%. That's a pretty strong response. Okay, every percentage change in the price, we get 2 times that as a percentage change in the quantity demanded. Let me contrast that with something. Okay, I'm going to have one in the middle here, but coming down here, suppose the elasticity is equal to 0.5, okay, 1/2, and we get the same 10% change in the price. Okay, what's going to be the change in the quantity demanded? Well, I'll do the exact same thing I did before. All right, I'll take the elasticity times the change in the price. That'll give me the change in the quantity demanded. So it's going to be now the percentage change in the quantity demanded is equal to the elasticity, 0.5, times the percentage change in the price, 10%. So this says that quantity demand is going to change by 5%. That's a much weaker response, right? It's clearly a much weaker response. Here, in response to the 10% change in the price, we got a 20% change in the quantity demanded. Here, in response to the same 10% change in the price, we only get a 5% decrease in quantity demanded. That's a much weaker response. One last, suppose that the elasticity equaled 1. And we get, again, the 10% change in the price. What's going to be the change in the quantity demanded? Well, it'll be the change in the quantity demanded is equal to the elasticity 1 times the change in the price. So here it's going to be 10%. So here we get a one-to-one sort of relationship, okay? For every percentage change in the price, we get a 1% change in the quantity demanded. Okay, so if the price goes up by 10%, quantity demand is going to go down by 10%. If it went up by 20%, quantity demand will go down by 20%. If it went up by 3%, quantity demand will go down by 3%. So is that okay? Can you see how that's working? Yeah.
Can the percent change in price be 0?
Yeah, the question is, could the percent change in price be 0, in which case there'd be no change in the quantity demanded.
But how would that affect the elasticity?
Oh, I see what you're saying. So I was looking right here. If the percentage change in price is 0, the deal is to get the elasticity, we've got to get some change in price, okay, because it's talking about moving along a demand curve. So I've got to get some sort of movement along the demand curve in order to figure out how strongly people will respond. If I don't get a movement along the demand curve, I can't figure out the elasticity is what that's telling us. Yeah, that's a good. First time I heard that question, it's a good question. Deserving of a donut. You need a good question too, or else he's going to have all the donuts. They're going to be sitting there, okay? Okay, oh, he'll share. Generous. We'll try to keep the director out of them too. Director infestation of donuts is something you don't want to see. Okay, let me give you some definitions here. Okay, first of all, when the elasticity exceeds 1, and I'll change colors. When the elasticity is greater than 1, we say the demand is elastic. So here, where can I do this? If the elasticity is greater than 1, we say demand is elastic. That means it responds strongly, all right? And that's this first one up here. When the elasticity equals 1, we call that unit elastic. Okay, that means it's a one-to-one sort of relationship. If you take more advanced math, 1 oftentimes gets called the unit. So that's what's going on here. But that means it's a one-to-one relationship. That whatever the change is in the percent change in price, that's going to be the percent change in quantity demanded. Finally, if the elasticity is less than 1, we say that demand is inelastic. And those are definitions. Okay, so that's a definition of elastic, uninelastic, and inelastic. Elastic means it's a relatively strong response. Whatever the change in the price is, the change in the quantity demand is going to be a larger percentage. So if it's elastic, we get a strong response. If it's inelastic, we get a weak response. Whatever the percent change in price is, percent change in quantity demand is going to be smaller than that. So as we go up this way, our response is getting stronger. As we go down that way, the response is getting weaker. That's good. Now, how would you calculate the elasticity? Well, you know, if I just gave you the percentage changes in the price and quantities, that'd be easy to do, right? You know, if I say, okay, if the price goes up by 6%, then that means that the quantity demanded goes down by 18%. Well, we can figure out that elasticity very quickly. You take the percent change in the quantity demanded, 18%, divide by the percentage change in the price, 6%, take the absolute value. The easiest way to do this is just ignore the percentage signs. So it's 18 divided by 6. The elasticity there would be 3. That'd be a pretty strong response. Okay, be elastic. So if I give you the percentage changes in the price directly, you just plug it in the formula, and you can get that answer. But suppose I don't give you the percentage changes. Suppose instead we get 2 points on a demand curve. Suppose I gave you this right here. Okay, here are 2 points on the demand curve, and I ask you, what's the elasticity between these 2 points? Okay, how would you go about doing that? Well, let me come back to this formula right here. Let me play around with this just a little bit more, and I'll do some more algebra here. So first of all, percentage change in the quantity demanded, that's equal to the change in the quantity demanded divided by the quantity demanded times 100. That's a definition of the percentage change. That's actually what the percentage change is defined as right there. And so now I divide that by the percentage change in price. That's going to be the change in price divided by the price times 100. And that's the definition of the percentage change in the price. I take the absolute value. Now, first thing to note is I've got 100 on the numerator and 100 in the denominator, so I can cancel the 100 out. That makes it easy for me. So now, this is going to be the percentage change in the quantity demanded divided by the quantity demanded over the percentage change in the price divided by the price, and take the absolute value of that. So I can use this now to calculate out the elasticity. This right here, this is going to be what we call the midpoint formula. And I'll tell you why it's called the midpoint formula in a moment. But you can use this to calculate the elasticity if we just have, if I just give you 2 points on the demand curve, like I give you these 2 points on that demand curve. So let me calculate the elasticity between these 2 points. All right, and look, I'm going to erase this right here. But what you might want to do to convince yourself about elasticity is to calculate the elasticity between these 2 points. And you'll get the exact same number for the elasticity, even though I measure the price in pennies and here I measure the price in dollars. You'll get the exact same elasticity number. I'll leave that for you to do. Let me just work over here and calculate the elasticity between these points here. So, okay, get rid of this here. That just confuses the issue. So what I want for the elasticity is equal to the change in the quantity demanded divided by the quantity demanded over the change in the price divided by the price, and take the absolute value of that. So let's again go from the top to the bottom. So it's going to be 18 to 22. So I'm going to have 18 minus 22. That's the change in the quantity demanded, divided by the quantity demanded. And now I face a quandary. I face a puzzle, a conundrum. Oh, we're changing directors. Oh, yeah, we're changing directors back here. So we're going up, we're going down. It's not clear. So going down, he says, yeah, it's hard to disagree. Hard to disagree. Okay, so here's my problem. What do I use for the quantity demand? Do I use where I start from? Or do I use where I end up at? Or do I use something else? You know, it's traditional to use where you start from. But that's just tradition. There's no reason you have to use where you start from. But suppose I said, okay, I'll use where I start from. I start from 18. So since I'm going down, I'll divide by 18. What that would mean is that if I moved up the demand curve, I said instead of going down the demand curve, let's go up the demand curve, then I'm starting from 22. And I divide this number right here, not by 10, divided by 22, the answer would be smaller. Okay, the elasticity would be smaller if I'm going up the demand curve than if I'm going down the demand curve. And that would be really, really bizarre, even more bizarre than our directors are, okay, that the elasticity would change if you go down the demand curve versus up the demand curve. You go, that would suck. You don't want that. So what economists do to avoid that is we use the midpoint. We use the average right here. So I'm going to use the middle point between 18 and 22. I'm not going to use 18. I'm not going to use 22. I'm going to use the average or the midpoint. That's why I made these numbers up. So they look sort of funky, but the average is really really easy to see. Middle between 18 and 22 is 20. So I'm going to put 20 down here. Okay, so that's my percentage change in the quantity demanded. Now for the percentage change in the price, remember I'm moving down the demand curve. So again, it's going to be going from $11 to $9, divide by, and again, what do I use? Do I use where I start from? Do I use where I end up at? Well, I'm going to use neither. I'm going to use the midpoint also. I'm going to use the average. So the average here is 10. I'm going to take the absolute value of that. Okay, now all it is just calculator work. Okay, so this is equal to, there's a negative sign, but the absolute value is going to get rid of it. So I'm going to get rid of it here. 4 divided by 20 over 2 divided by 10. And to do this, you invert the thing in the bottom and multiply by what's up top here. So it'd be 4 over 20 times, invert this, 10 over 2. So it'd be 40 over 40. So the elasticity here equals 1. And frankly, I didn't know what the elasticity would equal, okay, until I calculated it out. But it just happens that it's 1. So it's unit elastic between those points. So that's how we would calculate this using the midpoint formula. So let's see, there I just used that. So is that okay? You guys good with that? You can see how I did that? You could do that yourself. If it's written down on your note card when you take an exam. And look, I mean, on the note card, stick the formula in here, use your calculator. All right, that's all it is. Okay, now, no questions on that? Okay, let me show you now, come back here and do some more math. And I'm going to do this for a couple of reasons, do some more algebra. So let me come here. And let's look what I've got here. I've got, okay, the fraction up here, the fraction down here, and you divide. Let me actually get rid of this division sign here. And we know what you do. You take the thing on the top, you multiply it by the bottom, but you invert the bottom. Okay, so you flip the bottom and multiply it by the top. So it's going to be the absolute value of change in the quantity demanded, divide by the quantity demanded, times, and now it's the inverted bottom, price divided by the change in the price, okay? So I just got rid of that division sign there. Now when you look at this, what this tells you to do is you divide here first, you divide there first, and then you multiply second. Okay, so this is saying divide first, multiply second. But it doesn't matter what order you do it. I mean, you can divide first and multiply second, or you can multiply first and divide second. It's give you the same answer, okay? That doesn't matter. So I want to multiply first. So what I'm going to do is I'm going to multiply the top, I'm going to multiply the bottom. So this is equal to the change in the quantity demanded times the price over the quantity demanded times the change in the price, absolute value of that. So now all I'm doing is I'm just multiplying first and dividing second. That's fine. Next thing I want to do is I just kind of want to flip the order here. I just want to rewrite that. And that's definitely fine, okay? It's a change in the quantity demanded times the price over the change in the price times the quantity demanded, absolute value of that. So all I did was just reorder that. Now, one last step. I am multiplying first and then dividing second. I want to go back the other way. I want to divide first and multiply second. So what I'm going to do is I'm just going to take this right here and take that right there. I'm going to write this as it's going to be the change in the quantity demanded divided by the change in the price times the price divided by the quantity demanded. I take the absolute value of it. So all I've done now is I've just gone back to where I was before. That I'm just now saying, okay, I'm going to divide first and multiply second. Now, not algebra, but I want you to look at something. Here's the slope. Okay, the slope, and I should have been writing this as the quantity demanded. The slope is the change in the price divided by the change in the quantity demanded. What I've got here isn't the slope, it's the reciprocal. It's 1 over the slope. Okay, it's flipping the slope upside down, if you will. So this is 1 over the slope. So this is equal to 1 over the slope of the demand curve times the price divided by the quantity demanded. And we take the absolute value of that. And this thing right here, this is called the point slope formula for the elasticity. Now, I think it is a legitimate question to ask me, why did I do that? And you can see the cat is asking me why. Why did I do this? Well, I did this for a couple of reasons. Okay, first I like to show off the fact that I'm very good with simple algebra. Okay, this is simple algebra. I like simple things. I like the director. Do you get more simple than the director? Nah, not really, okay? But, so I like to show this off. So look, if you're talking to your folks this weekend and ask, how's your economics class going, you'll say, hey, the guy's brilliant. He's really good with simple algebra, right? So that you can acknowledge that fact out loud even. But there's another reason I did this. I can use this to show you something that you never would have thought of, something that I have no intuition why we get this result. Let me look at a straight line demand curve. And can I erase this right here? We don't need this anymore, right? Okay, I want a different demand curve. Well, this is going to be mathematically a little bit easier for me to handle. So come here. I'm going to have a nice downward sloping straight line demand curve. Here's the quantity, here's the price, here's my downward sloping straight line demand curve. And let me give you some points on this. Let's suppose when the price is 9, quantity demanded is 1. So that's a point on the demand curve. When the price is 5, let's suppose the quantity demanded is 5. And when the price is 1, let's suppose the quantity demanded is 9. Those are legitimately points on a straight line demand curve. I'm not lying or anything like that. Now let me ask, what is the elasticity at this point right here? Well, the midpoint formula is looking between 2 points. But this one right here, this is looking at one particular point. Okay, we can use this. If we know the slope of it, we can figure the elasticity at any particular point. So let me look at the slope of this demand curve. And so the slope of the demand curve, so the slope is equal to the change in the price divided by the change in the quantity demanded. And it's a straight line demand curve, so the slope's going to be the same everywhere. Let me look at the slope between these 2 points here. So the price is going from 9 to 5. So the price is going from 9 to 5. And at those 2 points, the quantity is going from 1 to 5. So it's changing from 1 to 5. Okay, so that is equal to 4 divided by -4. So the slope here is -1. So the slope of this demand curve is -1. Now I can use this so-called point slope formula because I know what the slope is. I can use it to figure out what the elasticity is at these 3 points. So let me look at the elasticity at this point right here. So the elasticity here is the absolute value of 1 over the slope, and the slope is -1, times the price, which is 9, divided by the quantity, which is 1. So the elasticity here is 9. And you may say, okay, big whoop, the demand curve is really elastic. Okay, the elasticity is quite large there. I say, okay, yeah, it is certainly large at that point. Let's look here at this point right here. So what's the elasticity at this point? Well, again, it's 1 over the slope, so it's 1 over -1 times the price, 5, divided by the quantity, 5. And so here the elasticity is 1. And you go, wow, whoa, whoa. You know, this changed from being elastic to unit elastic as you move down it. So it gets worse. Let's look at it right here. So right here, the elasticity at this point is 1 over the slope, 1 over -1, times the price, 1, divided by the quantity, 9. Here the elasticity is 0.11. What we see here is the mathematical fact that the elasticity changes as you move along a straight line downward sloping demand curve. That if you move down along a straight line downward sloping demand curve, the elasticity is going to get smaller and smaller and smaller as you move down here. It starts at 9, it gets smaller, smaller, smaller. Here it's 1. This actually turns out to be the middle point of the demand curve. And then as you keep on going down and down and down, it gets smaller and smaller and smaller, becomes more and more inelastic. I wish I could give you some intuition for this. I can't. I don't know. I can't see any intuition at all for this. And I've thought about this. I haven't thought about this for days or weeks or months or years. I've thought about this for decades, actually. So I've been teaching this class for a long time. And I really like intuition. If I have intuition into something, I know it, okay? I really, really want to emphasize intuition. I don't know the intuition, or I don't see the intuition. It's just math. It's just math. And so here's the bottom line. If you don't like this result, fundamentally, don't come complain to me. I'm an economist, not a mathematician. You know, if you think 2 times 3 should be 5 and not 6, you wouldn't come complain to me. You'd go find a mathematician, complain to a mathematician. Same thing here. Don't come complain to me. Find yourself a mathematician, complain to the mathematician about this. Because this is just math. I don't know any reason for it, but it's something you should be aware of. Now, I'll get asked a question. Are there demand curves where the elasticity is always the same? And with 2 exceptions, yeah. The demand curve generally looks like this. It's a rectangular hyperbola. There, the elasticity will always be the same along these. That demand curve looks something like that. There are a couple of other demand curves I'll show you in a moment where the elasticity is always the same. But along this downward sloping straight line demand curve, the elasticity is going to change. Would this ever be important to you? You know, it might be. Years and years and years ago, there was a proposal done in Orlando to have a high-speed, magnetically levitated train running between the airport in Orlando, International Airport, and Epcot. And a magnetically levitated train is cool. You know, it rides about so far above the rails. It's levitated up with magnets. And the thing was going to hit speeds of over 200 miles an hour on this route. And it sounded really cool. Unless you happen to own a hotel that wasn't on the Epcot property, that was, say, on International Drive, or you had a restaurant on I-Drive, because what you're concerned about is people get off the airport, they get on this magnetically levitated train, they go to Epcot, they just stay on the Disney property the whole vacation they're there. They never go on I-Drive, they don't stay at different hotels, they don't eat at different restaurants, all on Disney property. So all of the restaurants, all of the hotels not on Disney property got together to object to this, this proposal. Now, the state at the time had passed a law that said that they would help subsidize high-speed rail if it was going to be profitable. So the proponents of this magnetically levitated train got together a consulting firm, or hired a consulting firm, and they did work to try to show that this was going to be profitable. On the other hand, the opponents of this hired themselves a lawyer, and the lawyer hired a couple of economists, a colleague of mine in the economics department, and then me. And we were to look at the report that the other side put together, the consulting firm put together, and see if it was accurate, and, you know, obviously try to poke holes in it. So, okay, how do you figure out if this is going to be profitable or not? Well, in part, you need to know what the demand is. How much, at different prices, how many people are going to ride the train. So what they had done was they'd gone out to the airport and they'd surveyed people. And they'd said, hey, you can get on this train. It's going to take you from the airport to Epcot. You can put your luggage on it. They'll take it off when you get there, take it to your hotel room. Would you be willing to pay $40 a person for this? And he says, yeah. Okay, same deal. Would you be willing to pay $40? She says, no. Okay. Would you be willing to pay $80? He says, yeah. You're going to say no. Would you be willing to pay $120 a person? He says, no. Okay. So what they did was they asked 3 prices. And they got 3 points, ding, ding, ding. And then they used linear regression to estimate a straight line demand curve through those 3 prices. Well, it turned out what they'd done was they'd actually done something like this. Okay, so they had dot, 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 and then they had this linear demand curve through these dots here. Okay? So they had that straight line demand curve there. Well, they hadn't really asked a big range of prices. So they said, okay, we need to ask prices outside this range, like lower prices down here and higher prices up here. How can we get to the amount that people are going to buy these other prices? So, well, we'll calculate the elasticity between these points and we'll assume it's the same everywhere. I look at this and you can't do that. This is a straight line demand curve. The elasticity is going to change as you move along it. Assuming the elasticity is the same everywhere is like saying, well, for the purposes of this report, we are going to assume that 2 times 3 is 5. It's mathematically wrong. It's wrong, it's wrong, it's wrong. And so all their work, and they had thousands of pages. This was a long time ago when Excel was new, and they just run off thousands, hundreds actually, of Excel spreadsheet things saying, okay, this price, these costs, this thing, that, and they had all these scenarios worked out. All of them were crap, because they'd made this invalid assumption right here. And needless to say, I saw this because it was my job to look at the report, and I said, what are these guys doing? This is just wrong. And so we just had devastating critique of their report. As you know, that magnetically levitated train never existed. It might have been in part because we said this is not going to be profitable, because that just screwed up their numbers completely, and if you did it correctly, it wasn't going to be profitable. I think the major opinion was that they'd had some people who were really stupid plotting the thing out, and the track that they'd aimed for actually went pretty close to an eagle's nest, and you can't do that, okay, in the state of Florida or anywhere in the United States. So due to the eagle and the lack of profitability, you don't have that magnetically levitated train. But that was a case where these consultants were undoubtedly paid hundreds of thousands of dollars for their work. My colleague and I were paid thousands of dollars. I don't know what the moral is, that we did it right and they did it wrong. Yeah, I don't like to think about that moral. But in any case, that's an instance where you can see this elasticity stuff was used in the real world. It was used incorrectly by them, correctly by us. So is that okay? Is that all right? That's okay. Let me come back here. And let me take what I started out with as far as responsiveness goes. How responsive could a demand curve be? How non-responsive could a demand curve be? Let me run these actually. I'm going to flip these 2 around. I'll put them back up here. I'm going to have 4 demand curves side by side by side. Here are the middle 2. Okay, here's the price, here's the quantity. Here's going to be a steep demand curve like this. Here's going to be the price, here's going to be the quantity. This is going to have a flatter demand curve like this. And so this is less responsive, this is more responsive. So let me go less responsive, and this will be more responsive. And just to refresh your memory, look, what this means is if the price goes up a whole lot, quantity demanded goes down only a little. People don't respond very strongly to change in the price. If the price goes up just a bit, people decrease quantity, they demand a lot. So they respond strongly to this. What's the least responsive demand curve you could think of? Oh, and by the way, this being less responsive, I'm going to consider this to be inelastic. Now we know that's technically not right. Okay, because this is a straight line. And we know if I go up here high enough, it's going to become elastic. But when I want to draw a demand curve that is inelastic, and I will at some points, I'm going to draw one that's steep because, you know, that's our intuition. This over here, I'm going to air quote it. I'll consider this to be elastic. And again, we know that's not technically right because if we keep on going down here, it's going to become inelastic. But nonetheless, when I want to draw a demand curve that's elastic, I'll draw one that's flatter. Okay, so what's the least responsiveness you can envision? Well, think about a demand curve as it gets steeper and steeper and steeper. It could be vertical. Okay, that's the least responsive demand curve that you can imagine, this vertical demand curve here. That when the demand curve is vertical, look, here's the price P, here's the quantity Q. If the price rises a tremendous amount to P prime, quantity doesn't change. Okay, the quantity doesn't change no matter how much the price changes. So no matter what the percentage change in the price is, the percentage change of the quantity is zero. The elasticity at all points on this demand curve is equal to zero. This vertical demand curve right here is said to be perfectly elastic. That's as unresponsive as you could get. There's absolutely no response to a change in the price. What would be an example of this? Well, in the real world, there's nothing that's actually perfectly inelastic, but there are things that come close. Think about the demand for a life-saving drug, a drug that you need to live. Okay, that demand is going to be very, very close to being perfectly inelastic. It won't actually be perfectly inelastic. As the price rises enough, the quantity demand is going to decrease some. Let me give you an example. Okay, then I'll get your question. In sub-Saharan Africa, you know, it's South Africa, southern part of the African continent, a lot of people there have HIV. They're infected with, they're HIV positive. And there are drugs that you can take now that will prevent that from progressing to AIDS. If it progresses to AIDS, you're probably going to die. And in those countries, the drugs are cheap. Okay, let's suppose that in one country, the drug is $5. Well, unfortunately, in those countries, incomes are also low. So it's $5 a day. Suppose that you are making $8 a day. Okay, then you can afford the drug because it's only $5 and you're making $8. You have $3 left over for food, and shelter, and clothing, and so on. But you'll buy the drug because it's going to save your life. Suppose, on the other hand, the price of the drug goes from $5 to $10. Well, you're only making $8. You simply can't afford to buy the drug every day. And so the quantity demand is going to decrease because you cannot afford to buy the drug every day. So even for these life-saving drugs, you're going to see some sort of slope here. Not very much of a slope, but some. Now there's a question.
Wouldn't it be perfectly inelastic?
Oh, yes. Perfectly inelastic. Yeah. Could have been a donut for you. I'll give her credit for that, okay? Yeah, it's perfectly inelastic. So is that okay? You guys okay with that correction? Okay, so that's the least responsive that you can imagine. What's the most? Well, okay, we're coming over here. And we see as it's getting flatter and flatter and flatter, people are responding more and more and more. The flattest it could be is flat, okay? It could be horizontal, flat like that. That's the most responsive it could be. Here, if the price is P, suppose the quantity demanded is Q. Okay, if the price falls to P minus 1 penny, you're going to go out here until you cross the demand curve. You go forever. You just keep on going forever. You know, you go to infinity. So as the price rises to P plus 1 penny, well, if the price rises from P plus 1 penny, you go all the way back here. Nobody's going to want to buy it. Actually, the demand curve then runs up the axis here. At more than P, nobody's going to buy the product. So it goes from Q to 0. That's the most it could possibly fall. So here the elasticity is defined to be infinite, and this is said to be, and now I'm going to get it right, perfectly elastic. Okay, so every point on that demand curve, the elasticity is defined to be infinite, and we call that demand curve perfectly elastic. And you could ask, what's an example of a perfectly elastic demand curve? Well, think about the demand, say, for one corn farmer, that their corn is the same as everybody else's corn of that same variety. There's no difference in the corn. So if the price of a bushel of corn is $6, if the person tries to get more than $6, tries to get $6.10, nobody's going to buy their corn. Why should they? Because they can buy a zillion other people's corn all for $6. So nobody's going to buy their corn if they try to get a higher price. If they set a lower price, like go to $5.98, everybody in the world would want to buy their corn because it's exactly the same as everybody else's corn, only it's cheaper. So their demand would just explode. So if we think about the demand faced by, say, an individual corn farmer, the demand for their product probably is very, very close to perfectly elastic. So is that okay? Yeah.
I was just going to ask, does that make substitutes perfectly elastic?
Yeah, so the question is, does that make the substitutes perfectly elastic? Yeah, if you're a corn farmer, because you're making a product that somebody else is making the identical product, they're perfect substitutes for each other. That I don't care if I buy your corn or I buy his corn, they're exactly the same. All I care about is the price. And that's why your demand is perfectly elastic, okay? If you try to get a higher price than the market, what he's selling it for, I'm not gonna buy I'll buy zero from you, I'll buy all from him. If you just give me a lower price, I'm not gonna buy from him at all. Everybody's gonna buy from you. Yeah, that's a good question. Good answer too, by the way. Yeah, I deserve a donut too. A director hasn't done diddly squat to get a donut.
Up to potential.
Pardon?
So I'm already living up to potential.
Yeah. Yeah. Okay. Now, this has all basically been math. This is why I find this stuff not to be as interesting as a lot of the other stuff, because all this is math and algebra and so on. There's not much economics at all, but now finally I can bring in a little bit of economics. So we get this done, then we'll take our break. Okay, so let's see. You guys need these formulas anymore? Good, they're gone. You know, I like math a lot. Economists, you know, economics, PhD in economics is a PhD in applied math, basically. So I like math a lot, I use it a lot, but it's really economics is what I'm interested in. So let's get a little bit of economic use out of this before our break. There's something called a total revenue test. Now, before I talk about the total revenue test, let me first of all talk about what the total revenue is. It's always best to talk about what something is before you use it. So what's total revenue? Well, total revenue is equal to, as a business concept, for a business, let's say Paisanos, it's the price they get for a pizza times the quantity of pizzas they sell. That's their total revenue. It's the money that they have in the cash register at the end of the day. So here, let's suppose that Paisanos charges, oh, I don't know, $8 for a slice of pizza. And suppose that they sell 1,000 slices of pizza a day. Okay, now look, I don't know how many slices of pizza they sell. I have no inkling. $8 is not a bad guess for the price. But in this case, their total revenue would be $8 times 1,000 would be $8,000. At the end of each day, that's their revenue. That's not their profit. We have to subtract off their costs to get their profit. Now, suppose Paisanos is considering raising their price. Suppose they're going to go from $8 a day to $10 a day. They've got to be interested in how's this going to affect their revenue? How much revenue are they going to get if they raise their price? So suppose they raise their price to $10, and suppose that as a result, you know, the price goes up, people are going to decrease the amount of pizza they buy. Suppose they decrease a lot. Okay, suppose that now they sell only 500 slices a day. Well, in this case, their revenue is $5,000. So people responded really strongly to that change in the price, right? They said, whoa, it goes to $10. I'm not going to buy Paisanos. I'll walk down somewhere else. I'll buy something else. I'll go to Cava. I'll go to Chipotle. I'll go to McDonald's, for God's sake. Suppose, on the other hand, when they raise it to $10, people are going to decrease the amount they buy, but suppose they decrease it to 800. Okay, so their sales are going to go from 1,800. Well, in this case, look, their revenue hasn't changed. It's $8,000. The revenue hasn't changed. People haven't responded as strongly. Here they responded real strongly. They cut back a lot. Here they cut back, but not as much. So the response was less. Suppose they raise it to $10, and now they cut back to 900. So they respond much more weakly here. Here they cut back, from 1,000 to 500. Here they cut back from 1,000 to only 900. Here their revenue is $9,000. Here their revenue actually went up. So if people respond really strongly, their revenue is going to fall. If they respond only weakly, their revenue is potentially going to go up. Here, the revenues stay the same. So notice I'm using the magic word respond in here. How responsive, how strongly do people respond to this? So here's the deal. Suppose the demand is elastic. That means we're going to get a strong response. Okay, people are going to respond strongly to the change in the price. So if the demand is elastic, in this case, if you raise your price, so the price goes up, well, the quantity demanded is going to go down, and it's going to go down a lot. Notice the size of the arrows here. Price goes up, quantity demanded plummets, goes down a whole lot. So in this case, price times the quantity, this goes up, but this goes down a lot. The total revenue is going to decrease. That's this case right here. Okay, price went up by 20-some%. Quantity demanded just plummeted, okay, and went down by about 60-70%. And so the total revenue fell. Okay, leave more space in here, but let me come down here. Let's suppose the demand is inelastic. That means people don't respond very much at all. So here the price goes up. People decrease the quantity of the demand, but decrease it just a little bit. And so the price going up raises total revenue. This lowers it, but this is larger. So your total revenue is going to go up. And that's this case right here. Okay, here they raised the price, but people responded only weakly. Okay, they didn't cut back very much at all. And so the total revenue actually went up. Here's the midpoint. The elasticity equals 1. Price goes up. Quantity demanded goes down by the same percentage. 10% up, 10% down, 5% up, 5% down, whatever. And so the two effects just cancel. Total revenue doesn't change. That's this middle point right there. Okay? Now, that shows us what happens if the price goes up. We can do the same thing if the price goes down, right? If the price goes down here, well, people are going to respond strongly to this because the demand is elastic. Quantity demanded is going to rise a lot. And so here, the total revenue increases. Okay, yeah, you get a lower price, but you sell so much more that your revenue goes up. Here, if the demand is inelastic, you lower your price, quantity demand goes up but just a little bit, so you get some more sales, but you had to lower your price a lot just to get a handful more sales, and so your total revenue is going to fall. And here, if it's unit elastic, these two effects are going to cancel. Price goes down, quantity goes up by the same amount, same proportion, total revenue doesn't change. So that's the total revenue test. And you can show this mathematically. You got to use calculus, so I'm not going to do it. But I think the intuition is just really clear as to what's happening here. you know, what's going on with your total revenue. So this is something that you could easily envision a business using, that they're interested. You know, if they're a big business, they know what their elasticity is, and they can figure out from that, you know, back of the envelope, if I raise my price, what's going to happen to my total revenue? If I lower it, what's going to happen to my total revenue? They're really interested in their profit. But this is part of the picture because profit is revenue minus cost. So this is something that they're probably going to be pretty interested in. If you're a small business, you can maybe figure this out by looking historically at historical data. You know, you don't have economists on staff or financial analysts on staff, but you can say, hey, I raised my price a few years ago and my revenue actually went up. And that would say that, hey, the demand for my product may be inelastic. And that'll also help guide you as to what you want to do with your business. So is that okay? Is that all right? Is that good? Okay. Last thing to do in this chapter is talk about the economics, actually talk about what influences the size of the elasticity. But I want to take the break and wander somewhere and come back with something. How's that sound? So is that okay? Director, you good to take a break? Director? Guess he's